Hey guys, so today we are going to continue what we started in class, which is 8.1, 8.2 quadratic functions. We're going to break it down into 2 days. We're going to start by looking and observing the a and c values of this function, and then we'll focus on how the b value can help us when we graph. So we're going to start with a little review from what we did in class. Try these on your own. I'm going to go over them in the video right now, but we learned it in class, so it would definitely be beneficial for you guys to try on your own. All right? So, vertex. The vertex it's pointed to in the graph. The coordinate is 0. Remember, you start with the x, -2. Your axis of symmetry is the x value of your vertex. So the x value of your vertex is 0. And you always want to write it as an equation, an x equals equation. Remember, Buck's vertical line, undefined slope, x equals. This graph has a minimum because the vertex is on the lowest point of the graph. And the minimum value, look at where it hits the y-axis, is at -2. This parabola opens up. The y-intercept of the graph, you're looking again at the y-axis. Where does it touch? This one touches the vertex again, so it's touching at 0, -2. You always want to write a y-intercept as a coordinate. Okay, the domain is something we didn't do in class, but for all parabolas, because these arrows are basically pointing to the right and to the left forever, it's telling you that it's going to touch every single x value eventually. So we can write all real numbers or use the symbol for all real numbers, which again is just 2 parallel lines and then an R. Okay? And then the range. The range, you want to ask yourself, what's the lowest or highest point of the graph first? So this is the bottom of the graph. Sometimes it's the top, and you guys have to be able to see that. The lowest point of the graph starts at -2, but then the arrows say that it goes up forever. So when we're describing the range, the y values, it's all y values that are bigger than -2, nothing below -2. So all y values greater than or equal to -2. We'll do a couple more of those so that you know how to find the range. More about identifying the characteristics of the quadratic function. Try again. Try this one on your own. See what you know about this graph. Okay? I'm still going to go over it right now. Here we have a vertex at -3, because it starts at -3 and goes up 7. The axis of symmetry is always x equals the x value of the vertex. The y-intercept doesn't show, so don't worry about that here because we don't even have an equation to find out. I'm going to draw my x-intercept in, so that x equals 9. It opens down, meaning it also has a maximum at the highest point, 7. And we can use that maximum to find the domain and range. So remember, the domain for all of these, the arrows always basically point to the left and right, so it's all real numbers. The range, it's starting now at 7, but it's all numbers less than 7. So we just have to change the inequality symbol here. All y values less than or equal to 7. And that's it for that one. Okay, now let's talk about the a value of our graph. This a value right here tells us about how wide or narrow the graphs are. So in this case, they're asking us to compare it to the x² graph. They're giving us the x² graph. They're pointing it out. That's the original graph. We call it the parent function. Now, we only know how to graph these using a table because we haven't learned any of the shortcuts yet in this unit. So There's not too many shortcuts, but some points you can get a little easier than others. For now, you're just gonna make a table with a negative value, a positive value, and 0. So -1, 0, 1. You can do -2, 0, 2. And we're gonna find out what y values, what are the outputs when we plug them into our equation. So let's start with the first one. If g of x is 3x squared, then we're plugging the number in for x and squaring it. So for the first one, we're plugging in -1. So g of -1 equals 3 times -1 squared. You may use a calculator. By hand, -1 squared is +1 times 3 is +3. G of 0 is 3 times 0 squared, which actually is just 0, because anything times 0 is 0. And then lastly, g of 1 is 3 times 1 squared, which is just 3. And now let's graph this new parabola. -1, 3. 0, 0, 1, 3. Notice the symmetry between the first point, the last point, and the vertex. Now, what happened to the graph? Did it get wider or more narrow? We'll have fancier words for this, but for now we're going to say it's more narrow. And make a noticing that a value is 3. From the parent graph, the a value is 1. Keep that in mind. Let's do the next one. We're now plugging it into -0.2x squared. I'd like you to use a calculator and plug all these values into the calculator to find out the output. So -0.2 times -1 squared. And plug in 0. -0.2 times 0 squared, and 1, -0.2 times 1 squared. Get the outputs for each of those. All right, you should have gotten -0.2, 0, and -0.2 again. When you graph this, because they're decimals, for the sake of this problem, just try to estimate it's a number smaller than or between 0 and 1, but in the negative direction. So -1, comma, -0.2 is about right here. 0, 0 is here, and 1, -0.2 is right there. Notice graph got a little wider, but also flipped or reflected over the x-axis. Okay? Now take a look at the numbers, make your noticing. This 3 is bigger than 1. The graph got skinnier, more narrow. This graph, the second one, we had a number smaller than 1. The graph got wider. We also had a negative. The graph reflected over the x-axis. Let's take a look at this formula. Formally. Okay, if you are writing these notes by hand down, just write down exactly what I highlight for you. So I'd like you to write down that when your a value is between 0 and 1, so you'll see something maybe like a fraction or a decimal, the graph of f of x squared is going to be a vertical shrink. And that, I would write in parentheses, that means it becomes wider. So notice the red graph is wider than the parent blue graph. When a is greater than 1, you're going to write that down, there will be a vertical shrink. And in parentheses, I want you to write down that that means more narrow. You're going to see a skinnier graph. Okay? Now, the other piece we learned today is what happens when a is a negative number. So don't worry about all of this. I just want you to know that when a is negative, the graph opens down. Now this goes over it formally. You can have this down, but this is the most important thing you should know. The other piece of information, the formal words for opening down that we use, and I would like you to write down, is that when A is negative, or when A we say is less than 0, the graph reflects over the x-axis. It's a reflection. It opens downwards. So the important pieces here is all of that, and if you want to draw the picture out, you can. Okay? So now if we were to do the comparison without graphing, we would look at the number in front of x squared and ask if it's negative or positive, and we'd write the comparison. So I will go over the odds, and you guys will try the evens. In number 3, 5 is greater than 1. When the number is bigger than 1, the graph becomes more narrow, and we call it a vertical stretch. In number 5, it's a fraction, but don't be tricked. Put this in your calculator. You're going to get 1.5. It's still bigger than 1. So again, it's a vertical stretch. 7. Now we have a number less than 1. Oh, and we have a negative. So 2 things happen here. First off, it's a reflection over the x-axis. In other words, it opens down because it's a negative number. Now ignore the negative for a moment and focus on the point 1. The point 1 is smaller than 1, and therefore we have a vertical shrink. These words get a little tricky to remember which one's which. Think of a rubber band. If you stretched a rubber band, it would become skinnier. So more narrow means stretch. Shrink is going to be wider. Okay. Try 4, 6, and 8, and then there are your final answers. 4 is a vertical shrink. 6 is a reflection because it's negative and a vertical stretch. 8 is a vertical shrink and also a reflection because it's negative. Okay. Now we're going to add the C value and decide what that does. Remember, we're skipping that middle term, the B value. For now, we're focusing on A and C. So for these, I'm going to graph them for you, just a very rough sketch without a table. You should not be doing rough sketches here. The only time I'm going to have you do it is to know the difference between these graphs, which is right now, or if I say otherwise. Usually you should have a table with at least 3 points plotted, but we'll do plenty of that practice tomorrow. So they're asking you to compare the 2 graphs in the same coordinate plane, meaning in the same graph that I have here. And then what do you notice? So let's say this is your parent graph, meaning this first graph right here. Nothing's around the x squared, it's a parent graph. And then I will draw the new graph for you. X squared plus 2 would be right here. Notice what happens there. Then I'll do this one for us. Say this is 2x squared. And now 2x squared minus 2 would be down here. Okay. Think about what you notice. What happened when we added 2? What happened when we subtracted 2? There's no variable next to the C value. Keep that in mind. Okay, so make that observation, and now we're going to talk about them formally. Whenever you're adding a C value, it's shifting the graph up and down. If the C value is positive, like positive 2, it's moving or shifting up 2. If it's negative, it's shifting down 2. And based on the number, it tells you how many units up or down. Formally, I'll tell you exactly what to write down with my highlights. If C is greater than 0, there is a vertical translation, C units up. So I'd like you to write that when C is positive, it's shifting, and I'll write this in words, shifts up 2. Or sorry, up C values. 2 is the last example. And write it down formally as well. These are good vocabulary words to use. Vertical translation, 6 units, C units up. Shifts up C. When it's negative, I'd like you to write down, when C is less than 0, there's a vertical translation, C units down. And we don't say negative, that's why they have an absolute value sign. I would just write down units down. You can write down C. We'll talk about that in class. C units down. Okay? So, 0C is going to be helpful for some coordinates we get when we graph these more often. That's your y-intercept, always. So this C value, the number you see in the equation without a variable next to it, is a C value. It's just a constant, and it's your y-intercept. So for example, here, 0, 2 was the y-intercept. Here, 0, negative 2 was the y-intercept. And you can see that on the graphs. Oops, that was 0, 0. All right? So now let's move on and talk about them without graphing. Compare the graph. Now we have an A value to look at and a C value. We want to write every single translation. We're going to, again, skip the graph here. We'll focus more on that tomorrow. Here, our C value is negative 5. What that means is that the graph shifts down 5. That's it. You can write units. Let's talk about the A value now that we learned what this value does. A is 2, which is bigger than 1, and therefore there is a vertical stretch. It became more narrow because 2 is larger than 1. Let's try the next one. C value is 4. A value is negative 1/4. Sorry. So for the C value, that tells us it shifts up 4 units. Again, that means a vertical translation up vertically. The 1/4 tells us there was a vertical shrink. Shrink means it got wider. And because of the negative in front, it reflects over the x-axis. Try number 3. We're going to, I actually meant to skip number 3. We're not going to go over these. We'll save that for some algebra 2 next year. So